Good day, viewers. Welcome to the second video on array data structures in Python. In today's video, I'll be discussing on specialized array data structures, such as the Array.array object, the Bytes.array, and the Bytes.array object. First, let me give you a recap of what we discussed in the first part of this video series on array data structures in Python. In the first video, we discussed on Python arrays, and I told you that Python arrays are just a collection of elements, and each element is referenced by the index. For example, this on the screen here is a Python array having 5 elements. The first element is G, second is R, and the last is T. The element G is index 0. All Python arrays are indexed starting from 0. The element E is index 2, and the element T is index 4. So if you want to know the last element, just take the length of the array minus it by 1. Good. Now that we know the basics of Python arrays, let me take you to the first specialized array data structure in Python. That is array data structures you don't usually use all the time, but they are very important. First, we'll go to the Array.array class. The Array.array class are unlike lists. They are like lists but different from lists. Lists can take arbitrary data types. That means in a list you can add a number, you can add a floating point, and you can add a string all in the same list. But the Array.array objects are different because you have to specify the data type for that Array.array object, and you have to stick to that specific data type. Otherwise, it will throw you a type error. So it has a data type constraint. That is what makes it different from a list. And you can use the array object to store many elements, but they must all have the same type. So that's in a nutshell. The Array.array objects work like regular lists because you can expand them using append, you can shrink them using delete, you can extend them, you can mutate them, and whatever. So because of the similarities between the Array.array objects and a list, many programmers interchange them once in a while. If they want an array that needs only specific data types, they use this object. But if they want an array that can take arbitrary types of data, they use a list. Now let me show you how you can use this Array.array object. To use it, first we need to import the class. That's what I just did. You import the class with import array. Then let me create an object. Let me create an object. You create an object by calling the array method of the array class. And then the first argument is the type code. Now let me use the floating point data type. F is the floating point data type code. If you want a character type code, you use U. After specifying the type code, optionally, I can insert the element that will be in the array. Since we are using floats, I'll put 4 floating point numbers. That's it. So I've created an array object with specific or constrained data type. Now let's run it and see how it's represented in Python. I'll run it for you to see how it's represented in Python. This is the first time I'm running the terminal, so it might take time. Okay, it's coming up. It's coming up. Good. So you can see the representation of the array object. You can see that the first argument is, it says what we have here is a float, then we have the 4 elements and they are listed as if it's a list because it has similarities to a list. That's it. Now, because it's an array, you know what? You can index it. So let me say I want to print the second element in the array object. Let me print the second element in the array object. You will see that to print 2.0, you see it, so it can be indexed, and that's a feature of all arrays. So whenever any object can be indexed, you know it's an array data structure. Now the array object can also be mutable, just like a list. For example, if we have array object and I say the third element, I want to change 3.0 to 7.6. Good. Now let me print out the array object and let's see what it now contains. You see that the third element 3.0 will change to 7.6, but it shows 7.6 as a floating point number. You know, syncretically floating points has so many ways that the computer can represent them. That's why you see 7.59 with so many decimal points. That's it. So you now see that the array object is mutable, and because it's mutable, we can shrink it and we can expand it. To shrink it, we use the del keyword. Let's say I want to remove the fourth element. Now let's see how it looks like after I remove the fourth element. Okay, what did I do wrong? Okay, it's supposed to be array object here. Sorry, I was thrown off balance by that. Incorrect code. So let's show that. See, I removed the fourth object 4.0 and now has 3 elements. As it's shrinkable, it's also expansible. Let's append a float. Let's append a float 5.0. After appending a float, I'll show the representation of how it looks like now. Good. You can see it here. I've appended a float, so it's shrinkable, it's expansible, and now, just as I said, it's constrained to the type code you specify when you created it. In this, we specify that the data type it will contain are only floats. Now, if I want to insert a number, what the array.array object does is it casts the number to a float instantly, so you don't have any problem with that. But if I want to insert a string, you get a problem. Let's see. Let me insert a number at the fourth element. Let me change it with a number 9. Let me print it. You see that it casts it instantly to a float. To cast it instantly to a float. But if I change this to a string, it will reject it. Beautiful. If I change it instantly to a string, it will say type error. It needs real numbers, not string. So you see the data type constraint is always enforced in an array.array object. So that's one good object you can use when you want to constrain the data types of an array and you want specific data types. Maybe you want everything to be floats, you want everything to be integers, or you want everything to be strings. That's it. Now the second specialized array data structure I'm going to talk about is the bytes object in the bytes class. The bytes objects are immutable arrays of single bytes. What do I mean by that? By being immutables, I mean that the values cannot change after you create them. And single bytes means that it reads the byte sequence as single string of bytes. Just like in a string, it reads the words as unique characters, single characters in a string. That's how it reads the byte. So in conception, the byte array is similar to the string object in conception. Now let me show you examples of how you can use and manipulate the byte array. For example, if I create it, you just call the byte function. Now I created, let me add just 4 bytes. Later I'll show you that the number of bytes is constrained within a range. Let me show you how it represents the bytes, the numbers as bytes, if they are within the agreed upon range. It's not clearly shown. Let me clear this. You see, it appends everything with /x, and the raw data is a byte. That's what the B there tells you. Everything is a byte. That's it. And it has constraints. The constraint is that the bytes can be between 0 and 256. That's it. Anything above this range or below this range will give you a type error. So it takes, because they are all single bytes, so it takes byte ranges of 0 to 256. So because the byte object is an array, you can index it. This is it. You can index it. Let me take the third element and show how you can index it. So it tells us here that the third element is 2. That's what I printed out. Yes, because indexing is the main characteristics of arrays. So let me show you that if you give it a number beyond the byte range, it will reject it. Let's say let's try to mutate. Or let's create another, or let's just change the bytes here. This 3 I'll change to 300. So the 300 is beyond 256. So let me print it and see what error it will give to us. To give an error, it says value error, bytes must be in range 0 to 256. Do you see it? Byte must be in range 0 to, and as I told you before, the byte objects are immutable arrays of single bytes. That means you cannot change it after creation. But let's try and see if that is really the truth. Let's try and see if that's really the truth. Let's mutate the second byte in the bytes array. We want to give it 9. Now I'll print it out. I'll print it out and see what it says. It says value error must be in range 0 to 256. Okay, this is where the error is coming from. I was asking it to give us a type error. So it says type error. Bytes object does not support item assignment. Do you see it? It does not support mutation. It's immutable. Later I'll show you a byte array object that is mutable. So it cannot support item assignment, means is immutable. and because it's immutable, you cannot shrink, neither can you expand it. But let's try it. It's not bad to try. Let's see if we can shrink this. Let's take the fourth element. I say delete the fourth element. So I say delete the fourth element. Let's see if we can shrink it. It says no, type error. Object doesn't support item deletion. So you cannot shrink, you cannot expand because it's immutable. But if you want the ability to take a byte array and shrink it or expand it or mutate it or do whatever you like with it, then what you need is the bytes array object, not the bytes object, the bytes array class, the objects created from the bytes array class. I told you before that the bytes array, the byte object is immutable, but for the byte array object is mutable. Python developers created the bytes array object so that you can be able to mutate an array of bytes. So it has the same features with the byte object, which is an array, but the difference is in the mutability. Now let's give example of the byte array object. Let me give you example. To create a byte array object, what you do is just give it the byte array function. Like before, I'll just create 4 elements. Now let me print it out. Let me print it out to show its representation. My byte array. Good. You can see in this time the object is byte array, different from the bytes. The object is byte array, but there are differences. There are significant differences. Is one is mutable, the other is not mutable. Now, as in every other array, all arrays can be indexed. So likewise, this. If I ask you to give me the third element, to print out the third element, see what it will print out. Prints out 2. That 2 is the third element, so it's indexable. Now let's show mutability, because this is a mutable array of bytes, of single bytes. Let's show mutability. To show mutability, I say byte, my byte array, change the fourth element and make it the byte, the 10 bytes. So I'll now print it. Good. You see, it has changed the fourth element to slash. It's telling us the fourth element is /n. That's how it is represented as a byte. What if we give it the 11th element? This /sob/xob. So it's in hexadecimal format. That's it. So now let me show mutability. Something I have not shown. Let's shrink it. I'm just trying to show you the range of possibilities that it has. Let me shrink it to show mutability. If you know the range of possibilities, you can do anything you have been doing with all these arrays, just like a list. You just need to differentiate between mutability and immutability. Let me clear the screen and run it all over again. I'm trying to show mutability. We have 4 elements, but when we remove one, when we shrink it, you see it now has 3 elements. Now, what about being extensible? We append. What if I append the 6 as a byte into my byte array? What happens? Just to show the mutability, it adds 6 as a byte to the end of my bytes array. So you see mutability, it can be shrunk, it can be expanded. Now, before I conclude on byte array object, I want to tell you that it is possible to change a mutable byte array to an immutable array of bytes. How do we do it? What we just do is you just cast it using the byte function. So I'll change my byte, I'll pass my byte array to the byte function, and I'll ask it what is the type of my byte. You see, it will tell us that the type of my byte is a byte object. So I've changed it from being mutable to immutable. See, sorry, I just printed it out. I wanted to find out the type. So let's get the type to show that I've changed the byte array from being mutable. See, it says byte, and we know bytes are immutable array of single bytes. So I just change it to immutable array of bytes from a mutable array of bytes. That's all for the special arrays we can find in Python. Now, to give you an additional overview of what you can do with your knowledge of these array data structures in Python, I'll show you a question on the leetcode.com website that uses an array. This is a question 11 based on arrays. It's medium difficulty. It says it's a container with most water. We are trying to find the max area of a container, the maximum amount of water a container can store, given a list of lines or heights. For example, let me just use this graphic to illustrate the question. For example, you are given a list of heights. This height is one length, no matrix yet, is 1 length, this is 8 length, this is 6. Then we are told that if you join two lines, two heights together, which of them will give you the maximum area to contain water? If you join two lengths or heights together, which of them will give you the maximum area to contain water? Now let me give you a conception of how it can be solved. How it can be solved is that you take the length, the height, as the breadth of the area, and then you take the difference between two lines or two heights as the length. Then you do breadth times length to give you the area. Then you keep doing this for all the length and height combination. When you do this for all the length and height combination, then it gives you then look for the maximum area among all of them. So this will give you the max area. And when you get the max area, you can use your answer from the max area to get the lines or heights that gave you the max area. Now let's start. Let's show how this can be done. For example, I'll first write the question out. Given an array or list of contiguous heights or lines, find the max area between any two lines or heights. Good. Now, what's the list we are given of heights or lines? I'll take it from the LeetCode site. I just want to illustrate how you can use arrays to solve problems like this. I'll take it from the LeetCode site. Now, we need a container to store the areas we are going to calculate. So we say we create a list of a list for storing the calculated areas. So I call it areas list. First of all, it's an empty list because it doesn't contain any area. Then I'm going to loop through the lines or heights, comparing one to the the order. First of all, we'll get the first loop and second loop. So I'm going to loop through each of the lines except the last. Now let me show you what I'm trying to do. Now you see these lines. To get the max area, I'm going to say this first one, what if I compare it with this next one and take the area? Then this first one compare with this second one and take the area, with this third one and take, I keep on going until the last one. Then I move over, then this one I compare with this, then this, then this. I keep saving the areas. Then finally this one I compare it with this. So as I'm looping through the first indices will stop here, so that you can compare with this one. Then the second indices will start from here and stop here. So the first index will compare with the second index and so on and so forth. So that's how I'm going to compare. So I'm going to loop through the first index first. We'll start from 0. So I'll say -1. Don't go to the last line. We'll start from 0. Then we'll get the next index. The next index, it should be the start of the second loop. So we'll get the next index that will make up the second loop that we are going to use. So is the next line after the first index, so it becomes first index plus 1. Is the next line after. Then we use the next index to create our second loop. For second index in range, it starts from the next index and ends at the last line. I'm sure you are following through. So the second loop starts from the second index and ends at the last line, so that we could be able to compare the first and the second index. Now that we've gotten our loop right, now let's take the length for any two indices or lines. Take the length of any two lines as the first and second index. So the length, because the length is on the horizontal axis, is just the second index minus the first index. Length is just the second index minus the first index. Now we'll take the breadth. Now let me take the breadth. The breadth is the minimum between any two lines we are comparing. Now let me illustrate this without visualization. For example, if you want to take the breadth, or this is the length, the horizontal axis, the breadth is the vertical axis. If you want to take the breadth, for you to create a container, both of them have to be at the same height. So you just take the minimum. You just take the minimum of the two lines. For example, if you want to take the breadth of this one and this one, you take the minimum of this one. The minimum of these two is this one, which is 5. Do you get? So that you'll be able to create a container that can hold water. So we'll say the breadth is the minimum of the values of the first index. And the values of the second index. That's it. Now that we have the length and the breadth, we can calculate the area between the two lines. We can calculate the area. The area is just the length times the breadth. Good. We now have the area between any two lines. Now that we have the area, we have to store the area in our list. Store the area in our list. We also store the indices, so we can know which lines give the max area. So we say areas list dot append. Now I'm going to use a tuple to store the values for the area and the indices. You know why? Because a tuple is a good container for storing things very, very efficiently. I like a tuple a lot. I would have used a list, but I prefer using a tuple. So in the tuple, I'll store the first index, the second index, and the calculated area. And you can get the value from the tuple based on index. Like I told you before, a tuple is also an array data structure in Python, so you can get the elements based on the indices. Good. Now that we have our areas list, we have stored our areas. What's the next thing to do? After it has finished looping through all the lengths and the lines, then we need to sort the areas list. We need to sort the list containing the areas, so that the maximum will be the first in the list. So we now sort the areas list to get the max area as the first element in the list. So what we do is I will say areas list dot sort. You know, a list has a default sort method. Do you get? So I'll sort it based on the key. I want to choose a key. I'll use a lambda function as a key, and I'll tell it that just take the third element. Didn't write the lambda well. Just take the third element as the sorting function. You know that the third element is the area in the tuple. So take the third element in the tuple as the sorting function out, and then reverse through means sort descending. That is from the highest to the lowest. Now that we've sorted it, what remains is just to get the area. The area is now the first tuple. The first tuple in the areas list will contain the area, the maximum area. Get the max area. After sorting, the first tuple will contain it. So what we'll just do is I will say the areas list, you get the first tuple, which is index 0. Then the area in the tuple is index what? Index 2. That's the third element. So let's print it just to visualize what the answer to the question is. The max area is, you see, it will give us 49. The max area is to give us 49. Good, the max area is 49, and that's what we are supposed to get. So based on this code, you can find the max area for any lines, any length of lines. But what if we want to know what lines, what are the lines that gave us the max area? That's simple, because I store them in the tuple. The lines or height that gave the max area are print. So I use our knowledge of indices. The first line is height. I use our knowledge of indices. I just say areas list. Take the first element, which contains the max, and then the first, and then the first element in the list, and then the first element in the tuple. Then that will give us the first index. Remember, that's what we have here, the first index. So to get the height, we use the first index as the index to the height list. I'm sure you are following along. We use it as the index to the height list. And then the second height is, we do the same as before, but we take the second element in, this is the first element, which is the max. Then we take the second element. then we use it as the second index. The second index will now be projected into the height list to give us the height of the second line that produce a max area. So look at it now. Okay, I have a problem here. See, the list is not callable, so my parenthesis here is somehow wrong. Okay, supposed to be, I'm making it callable, I'm making height callable. It's supposed to be index, it's supposed to be index. I'm making it callable. Okay, now we are on spot. So let's see. Let me clear this so it will be clearly shown. Let's run it again. So you see that the max area is 49. The lines of height that give the max area are, the first line is height 8 and the second height is 7. So 8 and 7 give us the max area, which you can see from here. This 8 and 7 give us the max area that can contain the most water. So this is just an example of how you can use your knowledge of arrays and array data structures in Python to solve problems like this. Given a rectangular height, what is the max area? So that is all for today's video in array data structures in Python. I hope you did enjoy it. If you enjoyed it, I encourage you to subscribe to this channel and hit the like button. I'll be producing more interesting videos like this that will help you to transition from a Python 0 to a Python novice, from a Python novice to a Python hero in a short time. Watch out for my next videos as I produce more videos on Python. Don't forget, once again, hit the subscribe button and like this video. Thank you very much.